Good morning, everybody, and welcome back to Curiosity Corner Live. We're going to give everybody a few seconds to connect, but in the meantime, we go live every day, every weekday at 10:30, and with live demonstrations, experiments you can do at home, behind-the-scenes stuff, a lot of fun things. So go ahead and subscribe to our channel so you don't miss out on any of that. Good morning, Cedric and Isaac. Glad you could join us. Hope you're doing okay today. I know summer kind of came with a vengeance here. It's super warm. I'm not sure you guys are located, but here in Cleveland, it's been hot last couple of days here. Where even am I? They put me in some corner somewhere. Anyway, enough of that. So we'll get started. Hi, everybody. My name is Jared, your friendly Science Viking. There we go. My hair looked very bad in that shot. There we go. And I'm a guest engagement specialist here at the Great Lakes Science Center. So we are here to teach you all about fun science things. So with that in mind, today we're talking about data and graphing. Now, scientists collect data all the time. Data is, in simplest terms, information, pure and simple. For example, if you ever had your height measured, that's data or data. However you pronounce it's perfectly fine. Anyway, if there's your height measured, that's data. If you ever kept track of how long it takes you to run a certain distance, that's data, or how long you can run for. All of this is information that can be tracked, that can be written down. I think my helmet's on straight. There we go. Sorry, I got distracted. Anyway. So, example of what we're going to talk about of data and of how to interpret it, I have this ridiculous string of numbers. Now, what in the world do these numbers mean? They could be anything, to be perfectly honest, anything at all. Does anyone have a guess as to what these numbers are? Is where I'm going with this particular science experiment? So we're going to talk all about what these numbers are and the best way for us to display it so that it makes sense to everybody, depending on what you're looking for, what information you're trying to get out of it, that kind of thing. All right, time is up. These numbers are actually temperatures. So let's say a meteorologist is studying data and they write these down, just these string of 14 numbers. I can tell you these are temperatures, but I couldn't tell you anything beyond that just based on the numbers. What day do these correlate to? What scale? Are these Fahrenheit? Are they Celsius? Are they Kelvin? If they're Kelvin, that's a huge problem. That's not important now. Sorry. But what scale are these numbers on? What's our time period? We don't have near enough information. We don't have context to figure out what to do with these numbers. So to start off, I have made a table. This table displays our numbers as they correlate to what days match our numbers. There we go. So on Monday, it was 70. Tuesday, 73. Wednesday, 74. So on and so forth. Up until next week and next week's data. So now we have some context. It's kind of like if you take your height down, but you don't actually write down what year or what month, however, whenever you write it, whatever you measure your height in, but you don't write down what day it is, and you don't actually write down what the number is. It's just a notch on the wall. Doesn't make any sense. So, above our talking of graphs and how to display data, what if we wanted to explain the change from one day to the next, to the next, to the next? Well, for that, we would use a line graph. Our line graph starts at a particular day. Hold on. There we go. Our line graph will start on a particular day. And we can see on Monday, it was 70. Then the next day, the temperature rose to 73. Then Wednesday rose to 74, 80, 83. And it wasn't until, let's see, Saturday that the temperature went down from, what is this? Was it 80, 84 looks of things? Then went down to 79. And then kept sinking and then rose again towards the end of the second week. So we can see the change, of course, 2 weeks of our weather pattern. Yes, Vera, you can have a shout out. How are you today? You can have one too, Cedric. If you're referring to the shout out, yes. You're referring to the hoverboard I read about earlier. No, we don't have one of those yet. Moving on. So our next way of displaying information is what if we wanted to compare which days were hot and which days were cold? Relatively speaking, I still wouldn't define 68 to be cold, but moving on. We would use a bar graph. Our bar graph, as the name implies, is a graph that has a whole bunch of bars. As far as science naming goes, they're always pretty simple. There we go. No, hold on. There we go. I think that's. So we can see where some numbers match up. We can see which days were above 60, which were below, which were none. Which days were above 70, and which were below. We had a couple. Which days were 80 or above, and which days were above 90, which were none on our little graph on here. So we can see very clearly which days, and it had approximate how many days were very warm or just kind of warm. So that's a bar graph. So our final graph for our little presentation today is we're going to take the average. We're going to take what we had the most, and then we're going to split them up based on how often they appeared in our 2 week span. And for that, we have my favorite graph, which is a pie graph. Just simply because I like pie. So here is our pie graph. So get really close so we can actually. So our colors denote what our range is. So our blue piece of the pie, wherever that is our 60 to 70 range. It's not super clear, but you can still read it. Is our 60 to 70 range. Looks like our orange is our 71 to 80, and our gray is 81 to 90. So what I did to make this graph is I counted up. Oh, and then I threw that on the floor apparently. Anyway, I counted up which days had the most had these numbers that matched. So we have a 68, a 67, a 66, and 70. So we have 4 numbers that all fall. Hopefully I missed any. Could have happened. Which could have happened. What? No. Which all fall under the range of our 60 to 70. Our 71 to 80, we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. I think we have 7 numbers that fall in the range of 71 to 80. So finally, our last 3 numbers, 2 numbers fall under our 81 to 90. So that means that most of our numbers, more than half, fell under the 71 to 80. A little more than a quarter are 60 to 70, and then only 14% were 81 and above. So that is a bunch of fun ways that we can explore data, and we can show it to people so that it makes sense. Because if you just look at this string of numbers, we don't know anything about it. We don't have any context for temperature, for days, anything. But if we have a line graph, we can show progression. A bar graph, we can show frequency. And a pie graph, we can show our averages. Which leads us to our challenge for today. Now, our challenge I have for you is to go and make your own graphs. You can measure whatever you want. It can be, like I said, I think 4 times now. It can be your height. It can be how many flowers are in your backyard. It can be a whole bunch of stuff. You can measure whatever you want, and then you can make your own charts. Now, you don't have to go and print them up on a non-trademark processing unit like I did. You go and make them own. You can draw them, color them, whatever colors you want. You can do, honestly, whatever you want to do. What's important is that we have a key. Now, a key is this right here, as far as graphs and maps and things go. This is our key. This will tell us what our numbers and our colors mean. Because without this, these numbers have no context. And remember, in all of our graphs, all of our charts, context is very important. So go make up your own graphs, color them, get some construction paper, make them pretty, make them ugly. I don't care. It's your creation. Do what you want. But whatever you do, tag us, put them online, tag us with the hashtag StayCuriousCLE, because we want to see everything that you come up with. All right, well, that is our show for today. Thank you so much for joining me. Check back in tomorrow where my buddy Andy is going to tell you all about physical and chemical reactions, which should be lots of fun. There it is. All right. Hope you guys had fun today. So until next time, have fun, be safe, and as always, stay curious.